Robometrics now presents videos on entirely different topics in this playlist. The designing of a gearbox. Starting with the speeds, we have 5 different speeds available to create a gearbox: 6 speed engine, 9 speed, 12 speed, 14 and 18 speed. The structural formula for designing each of these gearboxes is given over here. So if we look over here, we have a unit called X and a unit called Y, where X will be the number of gears and Y will be the interval of speeds. So according to the arrangement, we can have a number of combinations to achieve the final stage. For instance, in this 6-speed engine, I can have two types of combination: 3-1-2-3 and 2-1-3-2. Similarly, for 9-speed, I can have only one combination, that is 3 number of gears with one interval and then 3 number of gears with the speed variation of 3. For 12 speed, I can achieve this ratio by 3 different combinations. So 3 into 2, that is 6, 6 into 2, that is 12, so 12 speed. Similarly, for 18 speed, again I have 3 different combinations: 3 into 3, 9, 9 into 2, that is 18. Here the number outside the bracket is the number of gears, so the final speed which we will be needing. So which one do we choose? According to the rules, the best efficiency that we'll get is when the value of X is in the descending order. So for instance, in the 12-speed gearbox, the value 322 is in the descending order. So I will be choosing this while designing the gearbox, until or unless it is specified in the question otherwise. Exception over here is a 14-speed gearbox. This will be achieved by making a 18-speed gearbox with 4 overlapping speeds. As we solve questions, you'll come to know about the 14-speed special case. Next, we have a number of formulas for the basic operations. Nz by Ni is equal to 5 to the power z minus 1. So Nz is the final speed given in the question and Ni is the initial speed or the minimum speed. The speeds are available on page number 7.20 in the design data book compiled by PSG College of Technology. The basic criteria we have to select when choosing the input speed for each stage is this one. The maximum speed divided by the input should be less than equal to 2 and the minimum speed divided by the input should be greater than equal to 1 by 4 or 0.25. If this case doesn't work, we can jump onto case 2 also, but just choose this rarely. Stick with case 1 itself. Case 3 is never to be taken. When we jump to the questions, it will ask 3 things: ray diagram, kinematic arrangements, and the number of teeth. All the 3 I will be calculating in the subsequent videos. So on page 7.20, we have a tabular column with 4 different columns and a number of rows. Selection of which number is required will be told according to the question that is involved. We just have to keep in mind these 3 points: that the decimal can be removed from any of the numbers. So for example, a number is written 1.80, I can take it as 180 or 0.180 or anything. 0 can be added on the right side, that is the number 100. This can be written as 100, 1000, 10,000, anything. So from point 2, we can judge that the first row and the last row are the exactly same thing. So we'll be choosing only one of them each time. The question for this video involving 12-speed gearbox is: a spindle of drill is to run at 12 different speeds in the range of 100 and 355 rpm. Design a 3-stage gearbox with a standard step ratio. Sketch the layout of the gearbox and indicate the number of teeth on each gear. Also sketch the speed diagram. I will be just showing the kinematic arrangement and ray diagram for this figure. The calculation of number of teeth will be shown in the next video, which involves 14-speed gearbox. So as we know, the maximum RPM is 355 and the minimum RPM is 100. The speeds required are 12, so 355 divided by 100 is equal to 5 to the power 12 minus 1, or 5 comes out to be 1.12. Page 7.20, we see that column 3, phi is directly given as 1.12, and both the speeds, that is 100 and 355, are available in the column. Therefore, I'll be directly selecting the speeds without skipping anything. So the first speed would be 100, then 112, 125, 140, and so on up till 315 and then 355. For the ray diagram, I need the structural formula. 12-speed gear would have the structural formula as 3 times 1, 2 times 3, and finally 2 times 6, which counts to be 12. So in the first part, that is 2 and 6, I have 6 intervals and 2 speeds. So my first speed would be 100 and counting 6 intervals, 1, 2, 3, 4, 5, 6. My next speed would be 200. For the determination of the input speed, I know that I have to put in 2 different formulas and test whether the values are coming as satisfied or not. The first formula is Nmax by N input. I am taking the input as 180 over here. As I have told in the previous video, it should be at least above the half of the range present here. The second condition is also getting satisfied, that is 0.55 is greater than equal to 0.25. Therefore, now I will be joining these two lines, that is from 180 to 100 and 180 to 200. This part gets completed for the first stage. Coming to the second stage, if I look at the structural formula, I have 2, 3, or intervals 3 and speeds 2. Therefore, I will be joining speed 180, that is the first speed. After 3 intervals, 1, 2, 3, the next speed I will be getting it as 250. Now similarly, I have to take the input value. Checking for the formulas again, I am selecting 224 as the input. Next, I have to make these two lines, that is from 224 to 180 and 224 to 250. Looking at the structural formula again, I have 3, 1, or 3 speeds with 1 interval. Therefore, my 3 speeds would be 224, then 1 interval 250, then the second interval and 280. Also, the final speed, the final input I have to select is the maximum input possible, which will turn out to be 355. Next, I have to join these 3 lines, 355 to 224, 355 to 250, and 355 to 280. Now 50% of my work would be done. Now what is left is making the different combinations. All I have to do is take the baseline and then work accordingly for the different combinations. So if I am selecting the baseline as 224 to 180, which is from here till here, the next combination would be 250, 200 and 280, 224, joining like this. The next reference would be 224 and 250 line. So the speeds I will be joining here are from 250 to 280, just above the line, and 280 to 315. So I've completed 2 baselines. Now I have to take 2 more baselines for the third part, or the first part which we had made. Reference as 180 to 100, I have over here 5 lines that have to be made, so that all the speeds would be taken care of. Looking at 180 to 100, just above both the speeds, I have 200 to 112, then 224 to 125, next 250 to 140, similarly 280 to 160, and 315 to 180. So I'll be joining these 5 lines to complete half of the speeds available. Next, I'll take the baseline or the reference line from 180 to 200, and similarly I'll repeat the same procedure to join all the speeds present. Finally, my diagram would look something like this. The kinematic arrangement for this will involve one more baseline in comparison to the other formulas we have studied or the other kinematic arrangements we have seen. Looking over here, I selected three input speeds. One was the highest, that was 355, one was 224, and the first one which I selected was 180. The fourth shaft would be the output shaft. Looking at the structural formula now, I have to draw 3 gears for the first arrangement, 2 gears for the second arrangement, and 2 gears for the third arrangement. All of this will result in a 12-speed gearbox, as stated in the question. In the next video, we'll be seeing how a 14-speed gearbox is designed. That video is very important because we'll learn 2-3 different concepts and learn how to calculate the number of teeth. Stay tuned. Robometrics.